Okay, so I am still Antonio Virdis from University of Pisa, and I'm gonna talk to you about two main elements, cellular communication and vehicular networks. And basically, we are trying to make them make love together. So on one side, our goal is to simulate cellular communication in the context of vehicular networks. But you can see that even on the other way around, we are going to simulate the vehicular network exploiting the communication from cellular networks. And here comes the idea of making SimuLTE, which is a simulator about LTE networks, interoperable with VANs, which is one of the most used vehicular network simulator within OMNeT. This work is made with Giovanni Nardini and Giovanni Stea from University of Pisa, but I would like to give credit to Giovanni Nardini, which is the mind behind this work, and I would like to thank him for his contribution. So, I will talk about why we needed to merge cellular communication and vehicular networks together. I will give you a very brief background on what is SimuLTE, and some ideas about modularity and interoperability and which are the main goals of this work, and the description of our proposed solution. So I would like to start with the idea of cellular networks, which usually I use. It's a slide that normally I use to present to students in order to understand why cellular networks are important. So you have the idea, of course, of 3G communication, so quite a good connection. You can use your cell phone for connecting basically wherever you are and obtain data from the internet. When moving to the 4G, the idea was generally to increase a lot the speed of your communication, so giving very high bandwidth, downloading videos and stuff like that. But the ideas shifting towards 5G, the fifth generation of cellular communication, is to increasing the amount of people, users that can access to this high bandwidth. And of course, you need to do this for a lot of users which are in some particular context, for example, a stadium with a lot of people, and you need to do this while you are driving your very fast car, so you need to still have your connection up and running while you are driving, and you still also need to control your washing machine and stuff like that, your all fancy IoT things that you have at home. So basically, the idea behind 5G is to have ubiquitous coverage, so coverage all around the network, have support to very high-speed mobility, and also a topic which is really interesting and is getting attention recently is the possibility of having direct communication, which is called D2D. Basically, having the user equipment, the cell phones, acting like a walkie-talkie, so talking together without the need of going through the base station. You can have this either in a broadcast, multicast manner, or even in a direct manner. On the other hand, we have the vehicular networks. Of course, I will not go into too deep details into this, it's not my field, but we have the idea of communication of vehicles to everything, where this everything might be vehicular to vehicular communication, V2V communication, for coordination in movement and stuff like that. Vehicular to infrastructure communication, so communication between vehicles and traffic lights or stuff like that, or also vehicular to pedestrian communication. Most of the things were a lot clearer in the video we saw thanks to Benjamin at the very beginning. So the basic idea is that we have vehicles that have to communicate with a lot of elements around them. And they are at least one of the endpoints of such communications. So here we have the interaction between those two elements. We have on one side, as we said, cellular communication, and on the other, vehicular networks. On one end, we have the cellular communication that can provide fast and reliable communication to the vehicles, and at the same time, they can provide multiple communication paradigms. As we saw, we can have direct communication, communication with the infrastructure, and stuff like that. All of this is very important, can be done in a plug-and-play manner because the network is already there. You do not need to develop your own solution on purpose, ad hoc solution for your vehicles. And you have already security and stuff like that. On the other hand, we can see the vehicular network as an element which is providing a mobility paradigm and another one of the many mobility paradigms for the cellular communication. So this will introduce new challenges for the cellular communication. For example, mass handover, bulk handovers. The concept of load mobility, which you can see as a lot of data traffic which is moving, a request of data which is moving together with the cars. And also we might have very stringent delay constraint because you can imagine for coordinating vehicles you need to have very stringent delay constraint in order to avoid crashes. There are plenty of use cases in the H2020 projects from Metis, from Cellular, all considering the cooperation between those two worlds. So I think this is enough for motivating this kind of work. So very quick basics on SimuLTE. I do not want to go into detail on this. Of course, you can, if you have questions, you can ask me. SimuLTE is an OMNeT-based system-level simulator, of course, for LTE networks. It is focused on resource allocation algorithms and on testing protocols on a large scale. Okay. It is INET-based, and it is built as an additional NIC interface for any kind of compound module. So basically, it's built to provide connectivity for pre-existing or ad hoc modules. And it tries, at least to try in our development, to follow the evolution of the cellular communication. Very simple overview of the network. We have the user equipments, which are the cell phones, and the classical base station, which is it's called eNode B. Communication can happen in both directions. We also have the ability to add external modules which are act as the other endpoints of the communication, which might be VoIP application or even more complex application server and stuff like that, which might be derived, for example, from the standard host from INET. The architecture of, for example, of the user equipment is classical layer architecture. The white parts, elements are taken from INET, so we have UDP and TCP application, layer, transport protocols taken from INET, same as well from the network layer. And we have the grade 1, which is the LTE NIC card, which provides layer 2 and layer 1 functionalities. In addition, we have the binder, which is kind of the oracle of the system, something that knows everything which happens within the system, and is basically used to keep track of all the connected modules and all the active user equipments which are in the network. We will get back to this later on. So, at this point, we have on one side SimuLTE, which provides connectivity for cellular communication, and on the other side we have VANS, which provides means by which we can simulate vehicular networks. So what are the requirements from VANS that we need to satisfy in order to interoperate with that? First of all, we needed to have a traffic interface mobility, which is a module from VANS, which is responsible for implementing the mobility within the system. We need the means by which we can create dynamically or destruct dynamically modules within the simulator, because as I was asking to Benjamin before, we might have a constrained space and we just decide to have a snapshot of what happens in that space. So we are taking a look at the cars entering, which will be created, and we are stopping having a look at cars that are exiting this kind of space. So we are going to destroy them. And this is important for two elements. The first one is that we need to create dynamically the modules or the compound modules within OMNeT, and on the other hand, we need to provide some kind of dynamic addressing, because those modules need to get an IP as soon as they are created. Finally, very high level, kind of an high level requirements. We have cars, elements which are moving around our space. So we need, as a real scenario, we might have those cars which are moving between and different base stations. So we need to support the handover mechanism, which is the mechanism by which the cars can switch, can change the base station dynamically. There was a first attempt, actually a first successful attempt to merge those two, to integrate those two elements, which is called SimuLTE. It's made by the Paderborn group, I think. And they introduced modification to both veins and SimuLTE to make them work. Basically, what we're doing, we're modifying veins to interact directly with SimuLTE. So calling all the SimuLTE function internally to create the elements and register them. The problem with this approach is that they were basically introducing a third framework, which were incorporating SimuLTE veins and also element from the OMNeT framework, which is quite a big problem, because this is a third package, which is it depends on the internal three packages, but all of them cannot evolve independently. Any modification to any of those three frameworks will basically cannot be incorporated automatically, will need a newer version of the old framework as well. So our idea is to focus on those two elements, which I think are the most important and maybe the best elements within OMNeT, which are modularity and interoperability. So the idea of having modules that can be implemented and managed independently and can also evolve independently as far as they maintain, respect the interface defined by the other modules, which is something that deals with the interoperability as well. So the idea is we take these three elements, these three frameworks, and we only made them interact using the facilities provided by OMNeT++. Okay? So this is our idea and our goal. So going to the requirements from veins, we address each issue one by one. The first one was the idea of addressing the mobility. So we defined a new module called car or LTE car, so whose idea is to create a car with application having, is there any problem? No? Okay. Having an LTE NIC card on board. So we decided to have two mobility modules, one for backward compatibility in order to have still the OMNeT mobility available, and the other one to provide vehicular mobility. So a module which is implementing the actual traffic interface. And of course, only one of those two modules will be active at a time. Very cool. Yeah. And what we did is we exploited the future mechanism. I don't know how known that is, how famous that is in OMNeT, but it's a very useful mechanism which will allow you to selectively enable or disable features within OMNeT. For example, in the case we were able to provide the SimuLTE framework without the need to include the veins framework as well, by just disabling the features from OMNeT dynamically. The cool thing about this is that you can both selectively include the elements in the compilation, but you can also have conditional programming, because you can use these to add directives within the code and exclude pieces of code if you want to. By using these, only one module will be active at a time, whether you are using one of those two mobility modules, and interested modules will register to the signals coming from only the active one. For what regards dynamic creation or destruction of modules, Veins uses two main functions, the add module and the delete module, to dynamically create modules which are cars which are entering the playground and deleting them when they are going out. Those two modules, those two calls are translated by OMNeT, and we implemented all the elements that are necessary to register the modules to the system to keep track of active nodes using the initialize and the finish functions, which is something that was not available before. Of course, the initialize and finish function will interact directly with the binder. So this is the reason why the binder is there. It keeps tracks of all the active nodes and their association with the base station. The other element we had was about the dynamic creation destruction was the addressing. So we have application within the system that, of course, need to communicate with the cars, even if those elements are being dynamically. So we included in the new car module an host auto configurator module, which basically provides an IP to the module as soon as it gets created. The application will still access to the car using its symbolic address, but the good thing is that that symbolic address will be associated to an actual IP in the network, so it will be used to route the traffic throughout the whole network. This solution is thought to minimize the impact on existing application rather than creating new ones, so you can use pre-existing application. At the node creation, as I said, we have the IP auto-configuration. When the traffic is started, can be started also at the beginning of the simulation, but every time before actually sending packets toward the car, the traffic application will check for existence of the actual node. So it will go like in a trial and error fashion. There are more efficient ways to do this, but they will probably need a lot of more modification to existing applications. So by just using this simple trick, you can still maintain your existing ones. And as soon as the node is destroyed, packets are dropped at the entrance of the LTE network. Again, even in this case, you can add more controls at the source application, but they will need, of course, a lot of modification to the original application again. Last element that we have was the need for handover support. Handover is basically the mechanism which allows user equipment to change their serving cell, mechanism which is called cell selection. Currently, we implemented a simple policy for handover, which is based on a best signal-to-noise interference ratio. Of course, different ones can be implemented, and using SimuLTE, of course. And this can be used also to use an initial association of nodes, which is not static. So we are not telling this user equipment is connected to that base station, but we can also kind of do a dynamic an initial attachment, which depends again on the policy for the handover, which is quite useful. An important thing that has to be noticed is that making an handover does not only implies modifying the serving base station here, but also implies modifying the routes within the packet core network, which is simulated within the simulator as well. So the change in the handover has also implication on the routing within the underlying network. Yes, we have time. We are very quick exemplary scenario. We have a very simple network, pretty similar to the one presented by Benjamin before. So we have two base stations and a certain number of cars that are moving using the Veins modules, Veins facilities. Those are the main modules, the main parameters taken from Veins, which are basically specifying which are the modules which will be involved in the traffic management, so in vehicular management. We can, of course, specify all the parameters related to veins the same manner by just referring to the original car element we just created. And as I told you before, we can either specify a dynamic cell association, so enabling endover, or using a static one. So even starting from this point, you can start working on the management of the endover. So you can decide, for example, that a certain car or a certain group of cars will stick to a certain node B or more complex policies, like the other complex policies. So. What are we doing right now? We are still developing the simulator, moving towards the 5th generation of cellular communication. We are thinking about something that is called cloud run deployments. So basically deploying the base station as cloud computers, separating the antenna part from the layer 2 parts into different points, which can have possibly instantiating on demand some of those base stations when needed. And this might have implication also in the vehicular field, because we can study solution to deploy ad hoc communication support in a specific zone dynamically. We are also moving towards the studies about mobile edge computing, which is somewhat similar to the concept of fog computing, but both to the cellular networks. So basically bringing intelligence and application to the border of the cellular networks. And of course, we are looking towards possibly including protocol aspects which are specific for vehicular networks, which are being included currently in the 5G framework. Of course, we are currently implementing some vehicular V2V application, for example, platooning application, which is the idea of coordinating vehicles in a platoon. And of course, we would like to persevere with the idea of interoperability, on possibly including other mobility modules, because of course cellular communication are just a mean to communicate, and also having different other mobility modules interacting the same way, so in a seamless manner, might be interesting. I think we will have a lot of other presentation about this topic during the summit, so we can discuss this possibly. Some conclusions. We discussed about the cooperation of cellular technologies and vehicular networks, and we analyzed the requirements coming from veins in order to be supported as a mobility system. We saw how to support interoperability between veins and SimuLTE by having a look at the including mobility modules, dynamically creating and destructing modules, and supporting endover. And we saw a very simple case study. The version of the simulator I just described to you is available starting from SimuLTE.com or following the GitHub in the framework of within the OMNeT. We decided right now to include this as a separated branch, an experimental branch, just because to see if we have feedback and if this is interesting for the community, we will include in the main branch of SimuLTE. And it's public available, and thanks for your attention. If you have any question.
Let's give a big hand to the speaker. And we have time for a couple of questions. I'm just going to run over here.
So yeah, thanks for your very interesting talk. Basically, I come from a background where we've done the same integration that Vanes LTE has done twice. So we have integrated it twice into the current version of Vanes again, and last time in the artery framework, basically. And basically what we've done is just we have taken the same steps that Vane's LTE did, so the same code snippets, and put them in the same places, and it works. And we even got handover working and so on. So I'm really interested in basically maybe talking later so that we can try to join forces there, because I think if we make this another module of the Artery framework, it would be really beneficial. Because for example, in our workbook we are also looking at channel selection strategies for vehicular applications and so on. And it would be really nice to have such a modular approach in there. So maybe we can extend that. But it's really nice seeing someone doing that in a modular way, basically, and not just putting code snippets in different projects. Yeah,
Okay,
that's just a comment, basically.
Yeah, it's really interesting. If you want to see another way, just another way of checking whether this approach will work also in another case. So it's very good opportunity.
Yeah, we have also some scenarios and applications already using approaches here, so that where we need vehicular communication and cellular communication, maybe we can verify our results with your approach and so on. Yeah.
Okay.
Thanks.
So, time for another question from the audience. Everybody's ready for lunch break, right? No?
It is unfair.
Just skipping over here.
Very simple question, just for my clarification. Like, you have all these scenarios with LTE. Of course, Benjamin also was talking about it. Like, have you guys considered into this the possibility that these cellular connections may belong to different operators who have different eNode Bs of their own?
Okay. It's a very interesting question. I'm just thinking about the implication of this, because I think it depends on whether you are interested in seeing the difference in policies between different operators, or whether some operators, some base station might have closed access or different bandwidth. I don't know. So there are.
Yeah, no, the question was like in terms of, because you have this sharing of information, right? So, and you know, car to car in a VANET.
Okay.
Because you have information now, a certain group of car owners may be using a, let's say, Vodafone connections. The others may be using Deutsche Telekom. So how, you know, in a situation like this, how would the sort of information flow, irrespective of because every operator would install their own base station.
Yes.
And they will have their own node, eNode B. Then how would they sort of, maybe it is already considered at a higher level to sort of exchange information. I don't know. That is why I asked.
The cool thing is that it will actually behave as in a normal network, because remember that everything is on top of SimuLTE is INET. So if you, let me just check if I have something that can give, okay, maybe this one.
The core network,
okay, in this case, I was implying that those two base stations are belonging to the same operator. And we have the packet core, evolved packet core network is also belongs of one operator. But you might also imagine here to have two different base stations with another evolved packet core network, and the two packet core networks will both converge to an internet router. So what will happen is that you will have one car here connected to this base station, another car here connected to the other operator's base station, and the communication will work this way, from this car to the base station to the packet core network of operator A to the internet, and then back to the second operator, down to the second base station, and down to the second car, exactly as in a normal network, as long as you do not implement different policies. So in a standard situation, you can already do this. It's just a matter of configuration. But if you are interested in cooperation of different operators, of also cooperation of different technologies, because please remember that this is the general shape of the car, but you can add a different NIC card and Wi-Fi card, or your favorite sensor network protocol over there, and it is the same problem in that case as well. Something that might be related to this is what I presented to you as both the C-RAN deployments and the mobile edge computing application, because as elements that are at the very border of the network, that might also be used for facilitating such kind of interaction between different operators or different technologies. Okay, there are a lot of work about this in the frame of the fifth generation. Really, I mean, a lot of work on this. By the way, staying to the simulator, you can do this. Just a bit complicated, maybe, but you can do this.
Yeah, I guess this opens up another load of questions then about combining different technologies, wireless technologies in iNet. So I think those are lots of things that we can discuss on the break. And another big thank you to the speaker. And yeah.